Hello everyone, myself Ved, and today I am going to start a very important chapter from General Chemistry, Chemical Equilibrium. In this chapter we will cover some important topics like how to write the expression of Kc and Kp, what is equilibrium constant and what is equilibrium and its graph, as well as Le-Chatelier principle, which is very important. Clear? So let's start with the equilibrium. So first of all we should know what is this arrow. So this is called single-headed arrow, which is a sign of irreversible reaction, irreversible. And this is called double-headed arrow, which means reversible reaction. So what does it mean? First of all, we should know this left-hand side is my reactant. This is called reactant. And this is called product. Okay. So in the top reaction, reactant is converted into a product, but in the bottom one, reactant is converted into a product and product is converted into a reactant. So this direction indicates forward and this is a backward. Clear? So this is the arrow. Clear? Now the next is, what is the concept of equilibrium? What is basically equilibrium? So here we can say, in equilibrium, it means the rate of change is constant. Okay, means if I am going to talk about with the graph, look at here. Suppose we have a reaction which is A to B. We all knew during the starting of the reaction A has some mole because it is reactant and B is always 0. Clear? So this is the graph and this is the reactant A. And this is B, because this is 0, suppose this is 0, this is 1, this is 2, this is 3, this is 4 and this is 5. This is a time axis, this is a time and this is a concentration. So during the starting of the reaction, A is going to decrease. Why? Because A is reactant. So reactant always decreases with the time. So this is going to decrease like that, suppose. And B is a product which will increase during the passage of time. Suppose this is. So as you can see, after this time, this time, suppose, the rate of change of A and the rate of change of B is constant. You can see this is a parallel to the time axis. Clear? So this zone is called as equilibrium. And this time is called as time of equilibrium, and this concentration of A is at equilibrium and this concentration of B at equilibrium. Clear? So if you look at, there is a constant called equilibrium constant, which will always be concentration of product form divided by reactant. So you can see here B is my product, A is reactant. So from here it is very clear, B by A. This is K equilibrium. Now in the graph we can see A value at equilibrium is somewhere around 3 mole, B value at equilibrium is nearly 2. So it is very clear A is higher than the B. So A is my reactant, this value is high. It means reactant is more in amount, which means the reaction's direction will be in the backward towards the reactant. Okay, as well as if you are going to talk about mathematically, so suppose this is B is my 3, B is 2 here and A is 3. So you can see this value is less than 1. So less than 1 means K equilibrium will be negative. So negative means it will be in the backward direction. The reaction will be in the backward towards the reactant. Reactant favorable. Okay. So this is a story of A to B equilibrium. Now there is another condition. Suppose this one. Okay, this is again A, this is B. Suppose the value here 0, 1, 2, 3, 4, 5. And this is the concentration of A at equilibrium. This is the concentration of B at equilibrium. This is the time. And here we have a concentration. So this is the time at which equilibrium starts. This is the time at equilibrium. You can see again there is a rate of change is constant. So this is my equilibrium zone. And this is the concentration of A at equilibrium, and this is the concentration of B at equilibrium. From the graph it is very clear B is higher than the A. So this is my reaction A to B, and K equilibrium is what? B by A. So B is a product, A is reactant, and in this graph it is very clear B amount is higher than A. You can see B is on the top and A is on the bottom. So which value is somewhere around 2 and this value is somewhere around 4. So you can see if you're going to keep values, so B is 4, A is my 2, so value is positive 2. So K equilibrium is here positive value. So positive value means greater than 1. Clear? So positive, what does it mean? So positive means, and also B is high. So B is high means reaction is favored in the product side, which means it is in forward direction. Okay, it is a favorable in a forward direction. So this is in forward. Now there is another condition, the third one. This graph is very important in equilibrium, so you should learn this carefully. This is A as well as B, both are same this time. Here we have A and here we have B. This is the time at which equilibrium starts. And you can see in this case, the A and B value is exactly same. So this means K equilibrium is equal to 1 this time. Okay. And if you have a reaction A to B, so you can see both concentration is same during equilibrium, which means it is neither in a forward, neither in a backward. So this is remain like A to B at equilibrium, constant. Okay. I saw a question in, I think, ESSER. Yeah, the updated one, and the question is like this. Okay, so there is a two reaction we have, A to B and C to D. Its constant is K1 and this is K2, and it is given in the stem K1 is greater than K2. Okay, this is a time, this is a concentration, and here we have curve 1, curve 2, curve 3, curve 4, and the question is which curve is reaction C to D. So take your time and try to answer this question. So this is the given, all this is given information. Okay, everyone is talking about so much graph in GAMSAT, and these type of graph, you know, in chemistry. Clear? So graph is always be from general chemistry, not organic. So, and the chapters will be what? Equilibrium, we have a graph. Kinetics, we have a graph. Acid base, we have a graph. Gaseous state, we have a graph. Redox, there is no graph. Okay, there is a table. So try to answer this question. So let me explain this. Look at here. So we all knew this is a reactant because this is the highest point of this graph, and this is the 0, 1, which is my product. Clear? This is product, this is reactant. One thing is very clear, in the given reaction, A and C is my reactant and B and D is my product. Clear? So we can say this point can be either A and C, and this point can be B and D. Clear? So now K1 is greater than K2. What does it mean? K1 greater than K2, it means K1 is a positive value and K2 is a negative value. So negative means in second reaction C is more in amount. This is more in amount, more. And this is positive, it means B is more in amount, more in amount. Okay. So between A and C, first figure out A and C. So you can see C should be more in amount. Suppose this is 0, this is 1, this is 2, this is 3, 4, 5, and this is supposed to be 6. So between A and C, I said C should be more in amount. So which point is highest? You can see 1. 1 value is nearly 5.5 suppose. This is 5.5 somewhere. Okay. So 1 is definitely C. Clear? These two graphs are the reactant, which is my A and C, and in which C should be more. So C is my 1. So if C is my 1, it means A will be 2. Clear? Why? Because these two only the possibility of reactant, these two lines. So in which it is very clear C is more. Why this C is more? Because C is reactant and the second reaction the constant is negative. So negative means backward. Backward means reaction will move towards the reactant side. That's why reactant is higher in amount. So we can see these two are the reactant. Which reactant is higher? 1. So 1 will be what? C. And the 2 will definitely be my A. Now let's figure out 3 and 4. So between products you can see B is higher in amount. Clear? Why? Because this value is positive and it will shift in the forward, so more product. So which amount is high between 3 and 4? 3 is high. You can see the values are around 2.5 and this is somewhere around 1. You can see 4 is somewhere around 1, 3 is 2.5. So 3 will be my B and 4 will be my D. So now it is talking about which curve is C to D. So C to D. C is my 1 and D is my 4. So 1 and 4 will be the answer. Clear? So these type of question is very important, and we can make another question something like that. Suppose this is your homework basically. We have again a reaction. One, two, three, 4. We have, this is a reaction P to Q, R to S. This is K1, this is K2, and I am saying K2 is greater than K1. So my question is, which curve is reaction P to Q? So take your time, you can answer this question and you can answer on a comment box. Okay. So now move to the next topic. Okay, so this is all about the concept of equilibrium. We did this. As I already told you, I will discuss only the important topics of this chapter. So this is a rate law. Rate law is basically more in chemical kinetics. So I'm going to skip this here. We already done this. Product by reactant, which is equilibrium constant. So let's talk about Kc in detail and Kp. Look at here. We all knew, suppose we have a reaction like this, supposed to be 2A plus 3B gives 4C, supposed to be. I'm going to talk about the expression of K equilibrium. So these numbers are called as stoichiometric coefficient. Okay. So K equilibrium will be what? Concentration of product divided by reactant. So product is my C, reactant is my A and B. So C to the power 4, A to the power 2, B to the power 3. Make sense? Suppose we have a reaction N2 plus 3H2 gives 2 ammonia. What should be K equilibrium? So K equilibrium will be what? Ammonia is my product, ammonia, and N2 and H2. So ammonia power 2, N2 nothing, H2 power 3. Clear? So this K equilibrium is divided into two types, Kc and Kp. Kc and Kp. Kc is called equilibrium constant in terms of concentration. Equilibrium constant in terms of concentration. And this is called equilibrium constant in terms of partial pressure. In terms of partial pressure. Let's discuss an example. Suppose we have a reaction N2 plus 3H2 gives 2 ammonia, and I am going to write the Kc and Kp for this. So if you are going to write Kc is same like K equilibrium, concentration of product divided by reactant. So product is my ammonia, reactant is my N2, and hydrogen is also. Look at this stoichiometry. Here we have 2, here we have 3, and here nothing. So ammonia power 2 and hydrogen to the power 3. Clear? What will be Kp? You know, in expression of Kp, square bracket is replaced by capital P. Clear? So if you are going to write down the Kp, it will be what? Capital P ammonia power 2 divided by capital P N2 and capital P H2 power 3. Make sense? This is the way we can write down the expression of Kc and Kp. There is a extra point, note point. Whenever any reactant or product is in solid or liquid form, then don't consider them in Kc and Kp. In this way, suppose we have 2A solid plus 3B gas gives 4C liquid plus 5D gas. So if you are going to write down the Kc or Kp, suppose Kc, then we know that the concentration of product divided by reactant. So as I told you that if anything is in a solid or liquid, then do not consider them in the expression. So this is liquid, cancel out, this is solid, cancel out. So you have a product only D and reactant only B. So D to the power 5 and B to the power 3. Make sense? This is a quite simple. Kp as well we can write down same way. Capital P of D to the power 5 and capital P of B to the power 3. Clear? You can see here we have a reaction. This is the stoichiometry constant A, B, small one, C and D. So Kp is what? Capital P, C to the power C, capital P, D to the power D, capital P, A to the power A and B to the power B. Kc and Kp do not have equal each other. They measure different things, one in terms of concentration, molarity, and one in terms of pressure. As I told you already, Kc is a equilibrium constant in terms of concentration. Kp is a equilibrium constant in terms of partial pressure. But one thing I would like to add here, K equilibrium, this is a very important point, you can write down somewhere. K equilibrium only and only depend on temperature, This is very important concept. It does not depend on concentration or whatever. It depends on only and only temperature. Means if you are going to change the temperature, then equilibrium constant can be changed. This is very important line, third one, and we are going to discuss. We have done this Kc and Kp for this reaction already. You can see the Kc will be what? I think we did this. Let me check. Yeah, this one. We have covered this Kc and Kp. This is very important one. Let me discuss this here. So I am going to discuss here factors affecting K equilibrium. The very first factor is representation. Suppose you have any reaction A to B and its equilibrium constant supposed to be 10. Okay, this is given. And I am saying what should be equilibrium constant for B to A? What should be nu Kc? So whenever you have any reaction and the reaction is reversible, like you can see this is a reverse form of the given one. So your Kc will be reciprocal, means it will be, the nu Kc will be the 1 upon Kc, means it should be 1 upon 10. Clear? Easy. Suppose I am saying we have a reaction PCl5 break down into PCl3 and Cl2, and I am saying Kc for this is supposed to be 5. Then what should be nu Kc for this reaction? PCl3 plus Cl2 gives you PCl5. What should be nu Kc? It will be 1 over 5. Simple. Makes sense? This is the first factor. Second factor is stoichiometry. Suppose we have a reaction A to B and I am saying Kc is supposed to be 10. And I am saying what should be nu Kc for this reaction? 2A to 2B. Nu Kc. So if you compare both reaction, you can see this time reaction is not reversible. It's same. A to B, A to B. The difference only is here. It is multiplied by factor of 2. You can see. So whenever you are going to multiply by any factor, the nu Kc will be what? The Kc to the power that multiplied number, that factor. So it is multiplied by 2. So we can see Kc value was 10. So 10 to the power 2, which is 100. Make sense? Easy. I have a question for you. Suppose this is a reaction N2 plus 3H2 gives 2 ammonia and Kc is 10. My question is, what should be nu Kc for this? So look at here. In this case, this reaction is reverse as well. This is reverse as well as multiplied by 2. You can see here you have 2 ammonia, but here you have 4 ammonia. You have just N2. This is 2N2. Clear? So it is multiplied by 2 as well as reversible. What does it mean? So nu Kc will be what? First of all, it is reversible, so 1 upon Kc. Multiplied by 2, so power 2. Kc value was 10, so 1 upon 10 to the power 2, which is 1 over 100. Make sense? So you can see this question, Kc is 10 for this reaction, and it is talking about what will be new Kc once you are going to reverse this. Simple, reverse means it will become 1 over Kc. Clear? Okay, this is very important. We have done this already. Whenever K is greater than 1, you can see. Whenever K is greater than 1, it means positive value. Positive value is what? It is favor in a forward direction, product are favored at equilibrium, and K less than 1 means reactant are favored at equilibrium. Okay, means more reactant in amount and here more product. We have done this already with the graph. What if it's not equilibrium yet? Everything we talked about so far, this chapter is based on the idea that reaction have already reached equilibrium, but if we have equilibrium, reaction is progress towards equilibrium but just has not gotten there yet, what happens? This is some question. You can see, for example, imagine that the following equilibrium constant has a Kc value 7. Now imagine that while running this reaction you measure A and B, and that A is 3 molar and B is 18 molar. Is there reaction at equilibrium, and how do you figure out? Listen, this question is based on another concept that is called as Kc and Qc. This is called as Kc and Qc. Clear? So here we have some point. Whenever Kc greater than Qc, it means it will be moving forward. Whenever Kc less than Qc, it will be moving backward. And whenever Kc equal to Qc, it will be equilibrium. Don't memorize these conditions. It will always be given in the STEM, but you have to figure out the application of this information. Okay, if you don't know how to write down Kc and Qc, then that is a problem. But don't memorize these conditions. You know, whenever Kc greater than Qc, forward. Whenever Kc less than Qc, backward. When they are equal, that means equilibrium. So what is Qc? Qc is called as quotient factor, which occurs at any time. It is not at equilibrium. It can be occurs at any time. And what is Kc? Kc only occurs at equilibrium. This concept will only be valid at equilibrium. At equilibrium. And this one at any time. At any time. And the important thing is that the Qc expression and Kc expression is exactly same. You have to write down just product divided by reactant. Easy. So you can see you have B 18 mole and A is 3 mole. So simply if you are going to write down Qc, what it should be? 18 divided by 3. Clear? Overall Qc is 6. Kc is given 7. So now we have to compare. So Kc is 7, Qc is 6, which means Kc greater than Qc. So Kc greater than Qc, it means it should be in forward. Easy. You can see here we will say forward. The reaction at equilibrium yet. Clear? The reaction direction will be in the forward direction. You can see this is the solution, and here the information. You can see does not equal, greater, less, everything. And the Qc expression is same as Qc. You can see B divided by A. This is the information which I already have done this. You can see whenever Kc or K is greater than Q, that means towards the reactant, and it will shift in the forward direction. And whenever Kc less than Qc, that means in backward, shift left. And whenever they are equal, that means at equilibrium. Again we have same question. You can see. Now this is very important topic, Lee-Chatterjee principle, and this is the last thing which is left in this chapter. So I am going to discuss this here. LC principle. LC principle. Suppose you have A and B like this. It is very simple. Whenever A is decreasing, B is increasing. An equilibrium job is to maintain the you have to just maintain the equilibrium. So suppose here we have equilibrium. So the amount which are lesser in the thing which is lesser in amount, the equilibrium always favor to that thing. So you can see A is lower in number or decreasing. So to maintain the balance, equilibrium will favor A. Clear? Suppose I am saying we have A to B and I am saying B is decreasing. So it means A will increase. So what should be direction of equilibrium? It will favor B. Makes sense? It can be asked in this way. The very first factor in LC principle is change in concentration of reactant and product. Change in concentration of reactant and product. I am going to talk about with an example. Suppose we have a reaction N2 plus 3H2 gives 2 ammonia. My question is, what should be direction of equilibrium when N2 decreasing? What should be direction of equilibrium when ammonia is decreasing? Okay. So simple thing is that N2 decreasing, it means equilibrium will favor in the backward side. Okay. So we can say equilibrium will favor in backward or left or towards the reactant. The second condition, ammonia, these conditions are different from each other. Okay, do not say like when N2 decreasing, so ammonia should increase. No, this is different, individuals. So N2 decreasing, so you have to just consider only N2 decreasing. If ammonia decreasing, so again you can see my product is decreasing, so equilibrium will favor towards the lower side, decreasing side, so forward. So equilibrium in forward. Suppose I am saying what should be direction of equilibrium when ammonia is increasing. Third question. So if ammonia is increasing, suppose ammonia increasing, it means N2 means reactant decreases. Clear? And I said that equilibrium will favor towards the lower one. So N2 decreasing, reactant decreasing, so equilibrium will be in backward. Clear? So this is the effect of concentration of reactant and product. Now second factor, effect of pressure and volume. Effect of pressure and volume. Whenever you have an effect of pressure and volume, always figure out number of moles. Look at here the relationship. Pressure inversely proportional to volume and volume directly proportional to mole. So if you raise the pressure, volume decreases. Volume decreases means mole decreases. So simply you can say pressure inversely proportional to mole. Clear? So if you raise the pressure, mole decreasing. Suppose we have a reaction N2 plus 3H2 gives 2 ammonia, and my question is, on increasing pressure, what should be direction of equilibrium? So first of all, you have to figure out number of moles in reactant and product. So product has 2 mole because 2 is stoichiometry, and reactant has how many mole? 3 here, 1 here, overall 4 mole. If nothing here, it means 1. Okay, so 4 mole here. So I am saying pressure increasing. So pressure increasing means mole decreasing. So mole decreasing means which side has lower mole? Product side has lower mole. So we can say equilibrium will favor forward. Clear? Suppose this is a question 1A. My second question, what should be direction of equilibrium if pressure is decreasing? So simple thing again. Pressure decrease means volume increase means mole increases. So which side has high mole? Reactant. So on decreasing pressure we can say equilibrium will favor in backward means reactant. Clear? So this is the effect of pressure, and volume effect is quite simple, direct relation. Suppose my question is what should be direction of equilibrium when volume is increasing? So volume increase means mole increasing. So which side has high mole? Reactant. So we can say equilibrium will be in backward, and lower volume means forward. Easy. So this is the effect of pressure and volume. Now the next is effect of temperature. According to a temperature, a reaction can be classified in two categories: exothermic, endothermic. Exothermic and endothermic. Exo means heat will always be released. Heat released. So the enthalpy sign delta H will always be negative. Clear? And if you are going to talk about the graph of exothermic, exo means out. That's why energy is released. And the graph is what? Suppose this is my this is reactant, this is product, and this is called transition state. This is potential energy. This is progress of reaction. So look at this point. I said exo means out. So out is what? Reactant is a bit outer than the product. Reactant should be the high if you compare with the product. So you can say reactant amount is a bit above to the product. That is called exothermic. And in exothermic reactions, in exothermic reaction, heat will always be towards product side. If you are going to expression, it will always be towards product side. This means it is exothermic. Now we are going to discuss the effect. Suppose I am going to raise the temperature, and my question is what should be direction of equilibrium if you are going to increase the temperature. Increase temperature means heating. So look at here. Temperature increases. Heat is given in the product side. So which side has high heat? If you are going to increase temperature, it means heat is more. So which side has high heat? Product side. So I told you already, if product has high heat, it means to maintain the equilibrium, what should be direction to maintain this reaction? What should be direction of equilibrium? If you have to balance this reaction, where should be direction of equilibrium? It should be towards the reactant, because reactant has lower heat, low temperature. Makes sense? Because temperature is always, heat is always high to low. Clear? So again listen me, if I am saying temperature is high, it means heat is given in the product side, so heat is higher in the product. So which side has low heat? Reactant. So equilibrium will favor towards the reactant side, towards the left, to maintain this reaction. If I am saying what should be direction of equilibrium if temperature is decreasing? Tell me. Decrease. So decrease means temperature decrease means heat decreases. So which side has lower heat? Product side. So equilibrium will be in the forward. Clear? Make sense? It will always be given in form. I will discuss a question. So first we should learn the effect of temperature. This is exo, and now we are going to discuss endothermic. Endo means heat gain. So heat gain means delta H will be positive. Okay. And heat will always be in the reactant side, like this. And if you raise the temperature, you can see Heat is present in the reactant side. If you raise the temperature, it means reactant has high heat. So which side has lower? Product. So equilibrium will be forward. Clear? And what should be direction if you're going to decrease the temperature? So decrease temperature means heat will decrease in the reactant side, so equilibrium will move in the reactant side, means backward. So this is the story of endothermic, and the graph will be like this. The graph will be this one. This is reactant, this is product, this is transition state, this is potential energy, this is progress of reaction. So you can see, I think I made mistake. This graph is exo, not endo. Let me discuss this again. Yes. Here we have reactant, here we have product. This is a transition state, okay? So you can see endo. Endo means inside. So inside is what? Reactant. Exo means out. Out means reactant is outer than the products. Here reactant is, if you compare product and reactant is a bit inside. So this is endothermic, okay? Now we have a question in this way. Suppose we have a reaction N2 plus 3H2 gives 2 ammonia. I am saying the delta H for this reaction is negative. Any value will be given like negative 270 kilojoule, whatever. My question is, what should be direction of equilibrium when temperature is increasing? Second question, what should be direction of equilibrium when temperature is decreasing? So exo is given here, delta H negative means exo, so we should write down the heat. Where should be heat? Towards the product. Why? Because negative sign. So now this is very simple. Temperature increasing. So temperature increasing means heat will be more in the product. So lower heat will be reactant. So backward. And temperature is decreasing. So product side has low temperature, which means forward. Clear? There is an extra point I would like to add here. Catalyst does not affect equilibrium. Does not affect equilibrium. Okay. It can affect only the rate of reaction, not equilibrium. So this is LC principle. You can see this is the effect of reactant and product concentration. You can see. Okay, look at here this question. This is N2O4. This is N2O4. The very first question is N2O4 is removed. Removed means decrease. Decrease means equilibrium will shift in the left. Easy. Now second, NO2 is removed. NO2 is removed means NO2 is decreasing. So equilibrium will shift in forward. N2O4 is added. N2O4 is added. If N2O4 is added, it means NO2 is decreasing. So again forward. Because reactant and product have opposite relation. If reactant increasing, product decreasing. If product decreasing, reactant increasing. So you have to always shift the equilibrium in the lower side, decreasing side. NO2 is added. NO2 is added, it means reactant decreasing. Reactant decreasing means left. Simple. You can see. This is the effect of temperature. Delta H is negative. Negative means exothermic. Exothermic means what? Heat will be here. Heat will be here means if you raise the temperature, this side has high temperature, so this side has low temperature. So equilibrium will be in the left hand side. This positive value means you can see 256 kilojoule, which means a positive value. That means endothermic. We have done this already, pressure and volume. Clear? Adding a catalyst, you can see catalyst does not affect the equilibrium. It can change only the rate of reaction by changing the activation energy. So this the catalyst effect on rate of reaction as well as activation energy is related to chemical kinetics. In chemical kinetics, we will cover rate law, order of kinetic, and some graphs as well. So this is all about the equilibrium. Okay. So in GAMSAT, whenever you have a general chemistry question, suppose there is a question. So a single question has 3 chapters. It can be equilibrium, kinetics, as well as acid base. So once you have an information of equilibrium, kinetics and acid base, then it will be easy to answer all those questions. Okay, if you have only the information of equilibrium at this moment, then you can solve only 1 to 2 questions from a stem, because only 1 to 2 questions can be from equilibrium, like LC principle. Okay, so in the next session we will cover kinetics. So please share and watch this one, and please subscribe my channel. I'm going to upload regularly chapters, in which I will cover the content and questions both, because equilibrium there is no direct questions, and once we are going to finish all the 3 chapters like kinetics and equilibrium, acid base, then I will discuss most of the questions from Acer and Azonil, because those questions is directly based on these 3 chapters. Thank you so much for watching this.